to say join Hangout.
I see it.
Woo! We're on the internet. Okay, so I guess people can join. Everyone should be able to join. Technically, I think everyone's in my circles in here.
Sharon and I are in. Victor, did you find it?
It says share privately.
Oh no, that's only the invite
That's
shared
the status,
privately.
right?
Yeah. The thing should be live. Anyone on the internet should be able to watch it. The spotlight thing is pretty cool. It like knows what the background is. It like blurs the background.
It does. Oh, Victor joined it. All right, Victor.
It gets confused.
I'm gonna hang up the phone now.
Hydra.
If you need to. But Victor, make sure you turn off your speaker and your make
I'll just
make
put
sure
on
you turn
headphones.
off your speaker and your video, or at least put in headphones and just mute yourself.
But he doesn't need to be muted. He can talk to us.
Oh yeah, never mind. You don't need to.
He just needs headphones so he doesn't get a feedback loop like crazy. And we gotta shut him up.
Yeah, you need headphones, but you can.
So are we doing
Here goes Infinity.
So I can talk.
So
Yeah. So what's happening right now with anyone who's watching talking is that only Sharon and I have headphones on. So we have had to mute all our computers because we have a microphone in this room picking up all our noises.
Oh, okay, that's fine.
So if you have
I'm a
a
gamer. I
question,
have
you
the
can
headset.
either speak up or you can type it out.
So I think we're going, right? This thing is on the internet. Do I need to invite anybody? Actually, you don't have a Google Plus, right? So I can't invite you directly. But you can see Titan's screen, right?
Yeah.
I mean, it's all the same stuff. Everyone's just looking at whatever's going on my computer. But yeah, if you make a Google Plus, just tell me and I will invite you.
Mikey, can you send me a link that I can read out to people?
Okay, I think we should have that link again. There we go. Links.
And then we should.
Oh, I turned myself.
And then we should minimize talking.
Yeah, like crosstalk and things like that. Okay, so in the chat, I'm going to post the link, which is the link to the event page, which should let anybody watch this thing.
It's trying to do something.
All right, so are we good to go? Is everyone ready? Is everyone like looking at the screen? They can see what I'm doing.
Yep.
Okay, so I guess I should aim it at KP, right? Because KP is the one who has the least experience with it. So then.
Me too.
Oh, and Aaron. So I've got two people that's good to have, because if not Veronica or Courtney, you get to each like, oh yeah, this all makes sense to me. So it's good to fill in people who haven't done any of this before. It's a good starting place.
My mic's already muted.
I heard you through this.
Well, we should hear everyone in the room with the mic.
No, but it says on the screen Tyson's volume level's going up, and it keeps flashing to his non-picture profile.
You can also mute yourself. So actually, I'll show you on my screen. You should see it. There's this little button here at the top that just turns off your microphone.
Yeah, it's off now.
Okay, cool.
Okay, so they should be able to hear everyone in the room. Looks like a bunch of people are in the chat. Things are going.
Oh, did the server start?
The server did not start.
Sometimes Skype is stupid because Skype uses port 80. There's actually, let's see if I can show you on my screen.
Oh yeah, interfere with WAMP.
So you have to look at my screen. If you go to Tools, Options inside of Skype, under Advanced, it took me a while to find this yesterday.
Do you have Skype?
And then Connection, there's this thing that says Use port 80. If you turn that thing off, it tends to fix a lot of problems with local hosts and the servers not running, because Skype uses the port it should not be using. Yes, get rid of Skype. Yeah, so if you have the problem, especially on Windows, where you see the WAMP server doesn't go all the way to green,
So we try the
it just stays in orange or something. Usually it's like the port is weird. So try to tell Skype not to use port 80 and then try to restart all the services of WAMP. If you want to restart the services, you just left click on the little green WAMP server icon, and just restart all services. And that will usually fix weird issues with Skype
correct.
screwing things up.
But it's not an issue of finding the program. It's that I don't find the program.
Okay.
We'll look at it a bit more.
Just you're all on the same page. Everyone good to go?
I can start watching the video.
Okay. KP's slightly behind us, but that's fine. So I guess a place to start. This is the program. This is Collector. So I posted some videos before on how to get to this point, which is things are running. So if you've made it this far, now it's time to actually start learning how to use this thing. And I know the first question lots of people have is, so this is designed to run on the internet. So you can give somebody. So right now we're running all this stuff off of local servers, but the main reason this is interesting is that you can run it off of an internet server. So here I have a link to the page we use at Cogfog. See, I'll run the newest version. So to run this way off the internet, so anyone, you can give them this link, they can run the experiment. You can see here's the internet version, so here's cogfog.com/collector, and here's the one that runs on my computer. They are identical. So I guess it's good to tell people from the beginning, to get the internet version, you need to have a server, and servers cost about $8 a month. You can go to something like DreamHost, or there's a few others, but relatively inexpensive, and there are things you can share. I think, how many people are using our server, maybe?
Probably have a good 12 people using our server.
Yeah, so if you
At
split
least,
it, we're looking at like 50 cents a month. They're really easy to just find a bunch of people, even across different labs, and split the cost of a server. And other than that, that's the only cost associated with using this program. It's completely free. You can have all the code. I don't own any of it. It's completely open source. If you want to modify it, you can modify it. I think the only restriction on the way the license works is that you can't sell it to somebody else. So you can't take you can't take the code, edit it, and then try to sell the new version of it. If you make edits, the version you make also has to be free. So it's designed to keep science free. So that was the idea behind the license, is that everybody has to make this free. There's no for sale version of this. And yeah, so what we're going to show you today is going to translate directly. You make one of these folders on your computer, you make experiments, everything runs the way you want it to. Then you buy a server somewhere, you drag that folder onto the server, and it runs the same way on the server as it runs on your computer. So that's the first thing I know everyone wants to know. How do I get this on the internet? How much is it going to cost me? It will cost you whatever, as many people as you can split $8 a month with. So pretty much nothing. And how to do stuff. Okay, so here's the main screen. You can ask questions on that, sure. You seem. Oh, I mean, is this recording? Yeah, say stuff. It sounds like I'm a crazy person talking to a room of nobody. It's like, who is he talking to? There's 7 of us here. So yeah, so the way this runs, here's the main page. Right now it says welcome to the experiment, and here's some text. All this stuff is, you can modify it. I'll show you how to modify it later. And the way we basically have people log in is they give us some identifier. So we ask for the UCLA email address because it's unique for every person, but you can ask them for anything, their first and last name, an ID number. If you're running on Mechanical Turk, we tend to ask for their MTurk ID. And for the version that is the most recent one, as of this Hangout, everything will be broken except for condition 13. So this is a good way to show you how to select your conditions, because if you leave it by default, it says auto here, which means that the program will cycle through the available conditions. So we've set it up to have 13 different conditions. If you leave it on auto, the program picks. So the first person logs in, they get condition 1. Second person logs in, get condition 2. That continues until we hit 13. And then the 14th person gets condition 1 again, and it just keeps cycling. And you can turn this little option off, which is usually what you want to do online, because even though it says auto and you tell people not to change it, some people will open it up and pick their favorite number. So you can turn that off again. This is all easy stuff I'll show you how to do.
So
Veronica.
if one person logs in and they get assigned to condition 1, but they don't finish, does the next person get to do condition 1, or does condition...
They get 2.
Do they get to 2?
The next person gets 2. Currently there's no code in there to fix it, but it's one of those things that we plan to do. But as is, yeah, the next person will just get condition 2. You hope dropout from conditions is about equal, that it will all balance out, and it tends to get pretty close. I've had some studies where one condition is very hard, and those are problematic, and that people drop out of that condition a lot, so it tends not to get run as much, which is more of a problem of, I think, bad participants, but technology cannot force them to sit at the computer. If it could, I would write it. Okay, so for now, what I'm going to show you is, here's how condition 13 runs. So you type some stuff in here. Under auto, you pick 13, and then you hit login to start it. So I'll just run through condition 13, which hopefully worked right now. So I hit login. They get an instructions page. Again, you can modify the instructions page. The way we set this up is to make sure people are reading this. It was a big concern we had is that they wouldn't read our instructions. They read it, and then they hit advance, and that asks them a question. Again, you write the questions yourself. And the idea is that you ask them some question that would require knowledge of what the instructions are. So in this case, it just says, should you pay close attention? Hint, the answer is in the instructions. If I say, oh, I don't think I should pay attention, it says, please carefully read the instructions again. The program's also logging how many times they missed this. So this is a good indicator of somebody not reading the instructions. It tells you how long they were on this page, and it tells you how many times they missed. So if they were on the page for 7 seconds and they missed 3 times, that means they clicked the first one, the second one, and then they got it on the 3rd time. So this is just how it runs. And this is a really simple experiment, just showing you word pairs. So mouse, what was the answer?
Minnie.
Minnie.
There's also Mickey.
But didn't it show me one? Oh, yeah, that's right. It's testing. Mickey. I don't know how many trials are in this.
So these are examples of study trials and then test trials?
Yeah.
Where you're studying Q target pairs.
Yeah, so right now, just sort of, this is the program running, but this is not all that interesting. What's interesting is looking at how the files, so I can't click here, this is a controlled time. Trying to click it, it won't let me. What's more important here is showing you how the files create this experiment. So that's what I'm going to do next. So this is just the basic, here's how you log in, but here's actually what's happening. So most of the stuff that runs these experiments is going to be in the experiment folder. So I've broken it down, and when you download Collector, there's a code folder, which holds a lot of the code you don't typically need to mess with. So unless you want more advanced features, you don't really go into code much. There's a data folder where all your data will be stored after you run it. So you can see here's instructions data. So this is me logging in, and it shows you how long I was on the page. So 4,800 and 376 milliseconds. How many times I failed the instructions, all that stuff. So your data goes there. No, don't download update. Documentation, this is actually not all that useful right now because it's pretty out of date, but soon, in the next few weeks, it'll be updated. What matters is experiment. So experiment is a folder 90% of the time. This is what you want to mess with. This is where pretty much everything happens. So the first file that's important is this file, conditions. So if you look at conditions, actually I should tell people this before. Conditions is a text file, but should be opened in Excel. It's a tab delimited text file. It's basically just a 2D field of information.
And we may be switching that to CSV soon.
Yeah, so they may be switching to CSV, but for now just understand that conditions is essentially a spreadsheet. That's the information that's in there. It's a spreadsheet of data. And most all the files you're going to mess with are formatted like this, where the first row the first row tells you this is what's going to be in the cells beneath it. So let me zoom out a little bit because condition notes is in the way. So we have this first row here. You see there's number, stimuli, procedure, condition description.
Zoom in a little?
Yeah.
It's hard to see.
Okay. Does that look better for everybody?
Yeah.
All right, so number, you just number your conditions. The number should be there in ascending order. Actually, the order doesn't have to be ascending. What matters is that there's not repeats of the numbers. So typically, I just grab, let's say this is an empty column. Oh, come on, Mac, you don't have a delete button. So delete.
Seriously?
It has a backspace button.
There's a delete.
Yeah, but it works as a backspace.
On my Mac keyboard plugin, I do.
Oh, I wish I had a Windows computer. Okay, so numbers, the whole point is that these are the numbers of your condition. So when I said it cycles, going from condition 1 for the first person, 2 for the second, and 3, these are the numbers it's looking for. So the second login, whatever row has number 2 on it. The second person who logs in will get it, and also I guess in this case, the 15th person who logs in. So that's what the numbers are. That's why the numbers have to each be unique. If you, for some reason, have 2 condition 1s, the program will run from the first line down looking for condition 1. This second one will never be run because it will find condition 1 here and then stop looking for condition 1. So it doesn't just cycle row by row. It actually looks for the number in the column. So just make sure. What I like to do is before I finish my condition, I just drag that number and say fill series. So I know I have unique numbers. But what's important here is these are the things that we give the program to run. So it needs a number, which is just saying when we cycle through conditions, this is how we determine which condition they're in. And then each condition is a combination of a stimuli file, which is where we store all the stuff we're going to be showing them, and then a procedure file, which says how do you want to display the stimuli you selected, in what order you want to display them, and what type of display. These other 2 columns here, or these other 2 cells associated with each condition, are just for your own personal use. Every line of data that gets recorded for this experiment will contain the values in these cells. So one is a condition description. So this is usually just to, instead of having to rely on the stimuli file and the procedure file to figure out what the condition is, you can give it a descriptive name, like, okay, these are your hard faces to remember. So if you want to look in Excel, every line of data that's generated by that condition will have the text hard faces to remember under a column that says condition description. And then condition notes, again, just another place for you to make your own notes about the condition if you want to say, okay, check these, or let's say you have 2 conditions that are essentially just counterbalances of each other. Let's pretend conditions, in this case, conditions 1 and 3, I'd say 1 and 2. Let's say 1 and 2 are just different counterbalances order of the same manipulation. You can just say manip A and then copy manipulation A. Oh, come on. Control C. So now in your data, you'll have the 2 counterbalance orders, so you can look at them separately, or you can just group them by, if you realize the counterbalancing doesn't matter, you can just say, well, treat everything that has manipulation A as the same condition. So again, these are just places for you to make notes. And yeah, so we'll look at condition 13, which is the one that's actually the only running one. So condition 13 has, again, you look at the number, find 13, that's the one we were running earlier. It has a stimuli file, which if you go back to the experiment folder, there's a folder called stimuli, so that's where the stimuli file goes. Open that up, and we see the stimuli file is called test stim shuffle. So test stim shuffle, this is a .txt file. But again, it should be opened in Excel or any sort of spreadsheet program. So we open it, we can see these are the stimuli we're using. Is this big enough? Can people see? Like, does this show up on your screens?
Yeah.
Not very useful.
I'm following along.
Okay, that's good. I mean, I figured you guys.
own.
I figured you don't need as much training as some other people. Okay, so does everyone who's watching see stuff going on? Okay, awesome. So this is the stimuli file. This is the file that contains all the stimuli you want to use for this condition. And again, like the other files, the first row is just saying, here's what stuff is going to be in this column. So all the cues, this was designed, so I wrote it as I do lots of memory experiments, so I designed it using names that made sense to me. But they, like, just because something's called cue just means that's the name we give it. So there's a cue column, a target column, an answer column. Soon one of these is probably going to disappear, probably answer, because target is generally the answer. There's a shuffle column, which we'll get to shuffles. There's shuffle 2, which again we'll get to. And stimuli notes are, again, just for your own use. So if you want to write down, whatever the study they came from, lots of times, we're pulling stimuli from another study we've seen. So let's say these are Cornell and Bjork. Cornell and Bjork, stim. So in 2 years, when you find your old data and you're trying to figure out what this study was even about, this is useful information here. You'll say, oh yeah, I got those stimuli from there. Or like, this is why I chose these stimuli. You'd say, whatever, hard pairs. So again, this is just stuff for your own use. And like almost everything else, every line of data that uses this stimuli will have the stimuli notes associated with it. So when you go back to your data later, every line of data that uses that stimuli will have that note for you. So really good to have, but otherwise doesn't do anything. And before we get into shuffles, I'm going to show you the other file. So we go back to the condition file. So each condition is a combination of some stimuli and a procedure that we do with it. So the procedure we're using for condition 13 here is in the procedure folder, and it's called the new.txt. So we go to the experiment folder. There's a folder called procedure, and inside of that there's a file called new.txt. So if you open new, we can see this is, so I like to bold the top row just to remind myself what's going on here. Resizing the column so everything looks nice and pretty. So here's what's happening in this study. What's happening is we're going to take this procedure file and apply it to this stimuli file. And the way it works is it just goes line by line. The experiment is essentially just running down this Excel file we create, and it's using the item, which is saying which stimuli should I use. So if the item number is 2, that means go to the stimuli file and look at whatever is in row 2 of the Excel file. So the number's a little weird, and the reason it doesn't start at 1 is because it's based off the Excel file. So if you have these two files open side by side, you're saying, okay, I want to show dog Old Yeller first. So I put 2 because I want to call whatever's in row 2 of the stimuli. Then 3, you can see I'm just progressing, going through all 20 of the things in the stimuli. So the item is saying which stimuli do we want to pull. And the next cell is the trial type. So this is saying how do I want to show this stimuli? What do I want to do with dog Old Yeller and all the stuff that I'm giving it? So here I'm setting it as a study trial type, which just means basically paired associate. So show me the word pair. So if we log back in, you can see how this goes. So I'm going back to logging in, random username under condition 13. Yes, I know the answer. So it shows some pair here. Actually, I should try shuffling to make this even clearer. So what's happening is you give it a trial type, and then you give it a timing. So how long do you want to show this stimuli for? Timing can have values of computer, which means the computer determines the default trial timing for that trial. I'll show you where you can set the computer timing, but it's basically saying use the default time. And when you set it to computer, they can't make it go any faster than you set it as. So if the trial is set to be for 8 seconds, they have no way to make it progress faster than 8 seconds. It has to sit there for 8 seconds, and then it goes on its own to the next trial. The other option is user, which is just, as you'd imagine, user timing. So they choose how long they want to see this trial type for. So if you put user, there's a button that says next or advanced or whatever, depending on the trial type, or submit. And they sit there until they click the button, so they have as long as they want. Again, we're recording how long they're on the trial down to, Tyson, are we close to getting to milliseconds?
Yeah, a couple of milliseconds.
Yeah, so within about
2, maybe.
Within about 2 milliseconds, we're telling you how long they were looking at the stimuli. So it's pretty good for a web-based experiment. So that's if you set user, or if you want, you can set a number here. So if you just want to say, okay, oh no, Excel is lagging. Okay, let's see if I can restart Excel. Oh no.
Actually, it should be capturing reaction time should be accurate to about the millisecond, but forcing the trial to proceed, controlling things is within a couple milliseconds. So it's harder to make something happen exactly on time, but it's easier to measure how much you were off by.
Yeah.
I find for practical purposes, typing in the number is super easy because
Yeah.
then you don't have to check in another place in the program to make sure you set that correctly. You can just see exactly what you're doing.
So yeah, so the timing, oh, there we go. So you can type a number, and this number will be the number of seconds you're on this trial. You can use decimal points if you want to do 3 point. You fixed it, right?
That fix is not in yet. But
it will be fixed very soon. For your
You can use
purposes,
decimal numbers.
that works. I thought you did put that in.
Yeah, we never did.
Oh, is it
You never
added stuff?
pulled
Alright.
that one.
Okay, so yeah, so for the purposes you care about, you can use decimal points. You can say 3.5, and this will just say, okay, after that much time, progress the trial automatically, and they can't force it to go any faster than that. And the thing that's not showing here is, oh no, my Excel is being terrible. Okay, I'm going to close all Excel windows. Don't save, don't save. Don't save. Okay, I'm opening it back up. If I open the, what was this stimuli file called?
Test stim shuffle.
And I need to rename these things, pretty terribly named.
It's new for that.
Okay, so I have both of them open again, I think, right? Because I want to see my screen. Alright, so we're back. So we can set these numbers, as Courtney said, sometimes it's easier if you just know you want everything to be 3 seconds long. You just say, okay, study everything for 3 seconds. And I guess, should I delete these posts for now? We'll set them to no, so they won't go. So I'm going to turn all these shuffles off. Give me 1 second, I'm hiding stuff from you. Old 2. So I'm going to show you how this experiment will run in the most boring case, which is basically do what PowerPoint would do for you, which is run these things exactly as I told you. So in this case, we've set up a really simple study. So we want to go through items 2 through 20, and we want to study all the items. So we'll study them all as word pairs. The amount of time, let's say, to make this fast, we'll study each for 1 second. So this would be a very rapid presentation time. So I saved this file, you updated the procedure, and I updated the stimuli as well. So this is condition 13, right? It's going to be the combination of these 2 files. So I'll ask someone who hasn't done it before. So Aaron, what's going to happen in this experiment? What are they going to see?
They're going to see first dog Old Yeller for a second, and then dog Beethoven for a second, and then study that.
I agree.
Did you turn the shuffle?
I did. I think I turned them off.
Okay.
Yeah, because I realized everything was shuffling before. It's
Yeah.
like, I can explain what's happening with shuffling. Shuffling is where this gets interesting. Okay, so if I log in, we should see what Aaron said. Again, I get the instructions. I know the answer, so we skip. There's Old Yeller. It's Beethoven. Lassie. So we can see we're just going down the stimuli file we're going through the stimuli file one by one because we didn't do anything special here. But this is kind of the most basic case of how this works. And most of the interesting stuff that we would care about comes in when we use shuffling and changing of trial types. So right now you can see everything is set to be studied. We went through all 20. I'll talk about final questions later. So now we're back in the main page, and now let's mess with these files. So let's say we want to try something more advanced. That's kind of the most boring case. So let's say instead of just studying, we want to study and we want to test the other half of the items. So we're interested in testing effects. So we're going to alternate between study and test. Again, this way, we'll see how there's faster ways to do this in the future. But for now, we're going to do this. So we study, test, study, test. So what should happen is we're going to go to, again, the experiment is going line by line. We're going to say, go to item 2, which is dog Old Yeller, study it. Go to item 3, which is dog Beethoven, and test it. And you'll see how just changing the trial types there changes the way we run the experiment. And again, never forget to save your files. I've had lots of people come and say, why is the experiment not working? And they haven't saved the changes they've made, so that's why changes aren't being reflected. So if you're ever in doubt, just save your files 4 times in a row, because I always panic that I didn't do it right. Type in something, go to condition 13, which is the only condition that works right now. Hit login. Dog Old Yeller. Dog, oh, I can't type Beethoven fast enough. So we can see it's alternating between study, test, study, test. Again, this is not as interesting, but this is kind of the introduction of how the trial type you select changes the way you view the stimuli. So we're just referencing a stimuli, and we're saying show it this way or show it that way. So again, this is all deterministic right now. This is stuff we could do theoretically in PowerPoint. I can make a PowerPoint that shows dog Old Yeller, then dog blank, and they have to guess Beethoven or type it.
You can also access the same item several times.
Oh, yes.
So you can say item 2, first you want to test it, and then later on you can use item 2 I'm sorry, first you want to study it, and then you want to test it later on. You can call it again.
So that what Courtney was explaining is what I'm trying to change the experiment to do right now, which is, oops, that should be 10. 10. Do we not have an even number of study tests? Okay, then that's dropped. So what's going to happen now is, as Courtney said, every time we call 2, we know it's the same thing. So we know 2 means dog old yeller. So if I call 2 and I say study it, and then 2 test it, what we should see is dog old yeller, and then dog blank, and we have to type in whatever the response is. To be very fast typists to go at this pace, but you can see in theory kind of what the idea is. So dog old yeller, dog blank. Oh, wow, that's fast. BETLAS. So, and the program, well, I can show you the data. What it's doing is also scoring me. So it knows that if I choose stimuli 2 and it's a test, stimuli 2 is dog old yeller. The answer is supposed to be old yeller. So it compares what I type in that box against old yeller, and it'll give me the percent match of the 2 texts. So how much percent are they similar? It also gives me a strict scoring number, which means you 100% match the original text. I think it's case insensitive. So if I got all the characters correct, it'll give me a 1. If I didn't get all the characters correct, it'll give me a 0. It also does a lenient scoring, which says if the difference, or if the match between the two, the response text and the answer is 75% the same, then score it as a 1. So this is meant to allow for typos. If the response is less than, or the response match is less than 75%, score it as a 0. That 75 number is just arbitrary. You can just change it. I can show you in the settings how to change it.
But even without changing it, the output will show exactly the percentage match, so
Yeah.
you can always go back into your raw output files and eyeball things.
Yeah.
And I think for our purposes, everyone's found 75 to be a very good cutoff. It catches most things.
Unless you're using really short answers, because then one typo can make it. Yeah, there's just lots of ways to get it. But 75 is generally, like, I spot check them afterwards, and it's almost never a problem in that they're not getting credit for something they should have gotten credit for, or they're getting credit for things that aren't correct. It tends to be a pretty good criterion. And again, Nate Cornell was using that in his version of the experiment, and I just kept using it, and it hasn't broken yet.
I have a question.
KP.
Do you always have to have a Q and a target for study trials, or are there other types of study trials to show?
Oh, there's all kinds of trials. So,
Okay.
so the experiment, the way it's designed is the trial type is just any construction you want. So there's actually a folder with all the different trial types in it. So you can just make your own trial type, and you say, okay, I want to show the Q, or I want to show just a target, or you can just have the Q and target contain information you want, and you say, I want to use this information to compute something, and then show that computed thing.
Okay. I want to show an image, or I want to play an audio file.
Yeah.
All of that also works.
Okay. Where do I find that file?
So that, where all the trial types exist is if you go back to the main collector folder, then go to code, there's a folder called trial types, which shows these are all the trial types we have. So there's like a copy trial type. I'll show you what copy looks like. Again, a lot of these are designed to run with word pairs. But I mean, in theory, you can design any trial types you want. You can just say, okay, I want to, like, okay, so actually this is a good instance of copy. So let's say we're doing some testing effect study, and I want to see the difference between testing an item after studying it versus copy, which is they have to type it still, but you can see the actual item. So every 4th item will change from a test to a copy. So here's study test, study copy, study test, study copy. You can get the point from there. So I changed that. I habitually, because I'm always afraid I've made changes, I save both of them every time, even if I don't think I've edited the other one. So I log into condition 13, and what I see is, again, at the really rapid pace, but study, test, study, there's a copy. So again, all is if you look in like the actual code, I guess I can show you the code a little bit. So if you open up copy, I'll open it up in Aptana, because I like Aptana for editing code. On Aptana, so there we go. So if you look at the code that actually makes the copy trial, the way everything works is PHP is just a language that shoots out HTML at the end. So pretty much everything you're seeing is just a web page. It's an HTML web page. So what PHP does is I can take a bunch of variables, but the output is always just give me some HTML response, which means create a web page, or you can have it, generate JavaScript responses. But the idea is, if you know some HTML, you just basically format how you want things to look at the end, and then you take the variables that PHP has, like, okay, put the Q in this place. So if you even look at this, so we'll get into the HTML later, but right here, so I say, okay, there's a study left, which is, this is the box on the thing on the left for the copy. There's the 2 word pairs on top. So on the left, I have, I open a PHP tag and say echo Q, which means just send out the HTML of the Q, which is just the word.
Mm-hmm.
And then in the middle, I have a divider. I just set a character I wanted the divider to be. If we want it to be a dash, I can just change that to a dash. And then here I say, okay, on the right, show me, and then echo the target. If for some reason I wanted to echo something else, I can change that value there, and it would echo something else.
But just make sure to change that in the stimuli file as well.
Yeah, so
okay. So
I
that's
guess
just the column name, right? So
yeah.
Q and target.
And this is actually gets to a good point, which I haven't touched on yet. It was initially designed to run memory experiments, but what's nice about the stimuli and procedure files is that you can just add columns to them, and that data just appears. So if for some reason you want to take 5 parameters and use them to do something, like, okay, I'm going to take all these 5 things, then I'll have PHP grab the 5 things, do something with them, and then give me that output. You can just add a column that's like P1, P2, whoops. So P1, P2, P3, say the 3 parameters, it's easier. And whatever, this is, 5, 10, 9, or whatever numbers you want to give it. Now when you call stimuli 2, you don't even have to have Qs and targets. If you're not using trial types that need Qs and targets, you can just say, okay, these things don't matter. Oh, lack of delete. So these things don't matter. It doesn't matter what's there. What matters is your extra columns you added. So now those columns are available to use in the code. So you can write a trial type that looks for whatever's in P1 and grab what's in P1, P2, and P3 computation you want to do, and then take the answer and echo that answer. So it was designed mostly to do memory stuff, but it's really flexible.
But your sound's cutting out.
Oh, it is?
Yeah.
Or do we have too much data going through? How does it sound now? Wah, wah, wah. Okay, I don't know why I thought I continued to your tone. But yeah, so the idea is you can add columns. The only constraint really is that don't name the columns something that already exists, because the program, like if you decided you want to call your column shuffle, the program will act very strangely, because it'll find that column and say, oh, that's a column that has a function already. Or there's functionality built into this column name, and we're looking for it, and it's got weird values. So just be careful when you add new columns in that they don't override old columns. But otherwise, if you never want to do QTarget experiments, you can just delete all the contents of QTarget. I think you have to leave the columns there, or the program will get mad at you. But also the order doesn't matter of the columns either. So you can just move them to the very end. You can just say, okay, Qs and targets aren't important to me, so.
And besides special columns, you also shouldn't have columns with the same name. Like if you had a Q and a Q column.
Mm-hmm.
Yeah, it gets confused if the columns override. But you can imagine you make a file that looks like this. You say, well, I don't care about Qs and targets. My experiment's doing something else completely different. So P1, P2, and P3 are what you care about. And the Q target answer stuff, you can just say, okay, delete all that stuff. I don't care about it. Oh, is there clear contents? Come on, Max. There we go. So you can have a file that looks like this, which basically says, I'm not using those things. They don't matter to me. Put them anywhere. The order doesn't matter, because all it's looking for is it's using the first row. It's using that name as a key to find the data. So the program's literally saying, if you say 7, it's saying, okay, go to row 7 and find whatever's underneath P2, and you can pull that value up. So it's pretty flexible, but most of the stuff it's built for is just because that's the stuff I do. But in theory, you can have it do anything you want.
So we've only really talked about the study trial so far, but there are things like text, if you want to put in text. I think, is that what it's called? Passage.
Yeah, there's passage for
if you want
study
text
passages.
Yeah. There's study pick if you want to have a picture. And so instead of doing left-right with Q target on left and right side of a colon, a study pick trial, for example, would put the picture in the middle of the screen, and you can choose to have a target or some sort of label or not. And then the target or the label will, the way these study pick trials are set up so far, would put that target below the picture.
Okay.
Yeah.
But you can change that too.
Right. Okay.
And what's nice is that basically once you build a trial type, if someone else wants to do a study like that, and they're like, oh, how did you do it? You're like, okay, here's my trial type file. And usually if you want to build a new one, the easiest way to do it is to go into the trial type folder, find the trial that's most similar to what you want to do, copy it. So let's say I want to do something that's just like the copy trial. So I copy that file, and let's call it new or Mikey is the trial I want to make, the Mikey trial. So I open this thing up, and instead of echoing the Q and the target on the left, I want to echo, for some reason, I want to switch them and see if they can recognize that something weird has happened. So I want to put the target first, and then I want to put the Q after, and then I want to put so down here where the study left, instead of giving the Q, I want to, let's say I have a different target, like, what's a good thing? So answer, let's say I use the answer column to put some information there. So now this trial will show the target on the left, the Q on the right, and underneath it, it'll have whatever value is in the answer column. Or let's say you made a new column, whatever it is. So it'll pull the value on the answer column and say, okay, put that, and then give them a blank to type into. So usually I tell people, find something that's similar to what you want to do, copy it, and then just start messing with the copy, because it's a lot easier than just starting out from scratch.
Is that good practice to do, to never mess with the current file?
Yeah, I wouldn't mess with the current files. So people used to do that because it was really a pain to put new trial types in, but now it's literally as easy as just copy a file, paste it, and then rename it to whatever you want the trial type to be.
Okay.
But you can, in theory, just go in there and mess with the original files. But then the problem is when you try to use the original, it doesn't work. It's hard to figure out what happened, and I'll probably just tell you, just download the clean version and use that because I don't know what you did. So yeah, and then if I decide, like, oh, that Mikey trial was a stupid idea, I just go back to my trial type folder and delete it, and my copy trial is left intact. I didn't mess with it at all. So, okay, I think that's the basic idea of what's happening here, and now I think the really interesting stuff is shuffling. Shuffling is what makes this useful and what makes it not PowerPoint, basically. It's how we do stuff that is more interesting. So let's go back to, so earlier I turned these off. So right now if you look at these files, so I have in my stimuli file, I'll delete these extra KP columns there. Delete those. So I have Q target, answer, and I have shuffle and shuffle 2. All of these are set to off, which means don't do any shuffling. Leave everything exactly as it is. With shuffle off, the experiment is completely deterministic. It means when I say 2, look at column number 2, and pull just what's in column number 2. Courtney.
There's also shuffle capabilities in your procedures files.
Yes.
So just keep that in mind, I guess.
Yeah, we'll get there. I'm going to explain the easiest shuffle, and then I'll have you combine the two to do better stuff. So right now, if we're just looking at the stimuli, you think, okay, so let's go back to the easiest case study we did earlier. We're saying we want to see trials 2 through 19. Actually, we can do 2 through 20 here, because if you look, again, the number 20 corresponds to the 20th row in the stimuli, so we want to study everything in our stimuli file, and we want to study everything as a study trial, everything for 1 second. So I can just copy all this stuff here because I'm going to use the same parameters everywhere. So right now, it's as it was set up before. This would just go dog, cat, and the exact order. But if I go into my stimuli file and I say shuffle all these as I can make any name. Let's say stim. So if the name is not off or if the name isn't off, that means these are now being shuffled. And the way the program shuffles is a very dumb shuffle. It literally just goes through the stimuli file and says, look at the name in the shuffle column. If the next column has the same name, then these are now part of the same group. So I'll do grouping by color because I think that makes sense to my head.
So what if instead of off it was just blank? Will it still shuffle, or will it treat a blank like off?
I think it treats a blank. So if I did this, at least as I remember it, I had to look at the actual code, the program would say it's blank. And then the next one would say that's also blank. These two blanks go together. So treat them as those belong together because they're both the same thing. So literally all it's looking for is, does this cell equal the cell beneath it? If it does, these two are in a group. So in this case, if I ran it, it would say, at least in theory, I think that's how it should work. We'll find out in a second. It should treat dog and old yeller as a group and shuffle them. And then it should treat the rest of these stimuli as one big group and shuffle them. So we'll give them different colors. So in the first two trials, we should see dog Old Yeller and dog Beethoven. And the shuffling is per participant. So when a participant logs in, the program goes to the stimuli file, shuffles it. So let's pretend it said, okay, these two go together, all these go together. So I'll kind of approximate what shuffling does. So what I'm doing here is basically showing you exactly what the program thinks when it's doing this. So I'm just having Excel generate a random number for me. Oh, that's going to override my coloring, isn't it? Yes, it is. Come on, Excel. Okay, so I'm generating random numbers here just to show you kind of how the shuffle works. So the program says, okay, these two belong together. Now shuffle them. So effectively, I'm shuffling them by saying sort by the random number I just made. So I made a random number in column I, and I sort. So in that case, it didn't change. Let's pretend it does change. At least let me prove it can change. Are these always the smaller one? Is okay. Then let's sort from the largest to smallest. There we go. It's flipped the two, so by chance it didn't flip them. So the program comes through and says, okay, look at these two, treat them as a group, put them in a random ordering. And then it comes through and says, okay, all these are the same, treat them as a group, and now put them in a random ordering. So again, I'm just sorting by that column I, which is some random number. So this will renumber the experiment. And it basically does this, and after it does this, it goes to the procedure file and says, give me 2. So what's in 2 now is dog Beethoven. It isn't dog Old Yeller anymore. What's in 3 is now dog Old Yeller. What's in 4 is Lassie. What's in 5 is Batman. So you can see basically it does one shuffle here, and then it says, okay, now look at what column I'm pointing at, and give me whatever ended up there after the shuffle happened. And the shuffling only happens once, so it's important to know that if I say study 2 3 times in a row, it doesn't do a shuffle between every time. It'll say look at 2, and look at 2 again. That what's in 2 isn't going to change. It's always going to be the same thing because it did one shuffle. And now for that participant, whenever I call 2 for them, it's the same thing for that person. When the next person logs in this condition, 2 will be a different item, but what we do know is that 2 is studied 3 times in a row, whatever 2 happens to be. We just know we moved what is in a position, and then we called that position 3 times. So I'm going to save this, and you'll see how this study runs. So what should happen is we're going to either study dog Beethoven or dog Old Yeller 3 times in a row. Then we're going to study another, whatever items, whatever happens to be in 5 through 20, we'll study once each in a random order. So before they had groupings. So can I roll this back without? How do I roll this back to the old version? Well, I know how to do it. I can make. Okay, so I showed you how the grouping works. I'm going to turn it back to the old version so it doesn't look pre-shuffled. So go to Git. Oh, no, Git. Yes, reset my changes. Okay, so my file should now look like it used to look. Collector, experiment, stimuli, test stim shuffle, is that what I called it?
Yep. Mm-hmm.
So here we can see it has the same grouping. So essentially, I forgot I changed those. Okay, so this is, we'll call this group 1. So actually, let's do this. Treat all the dogs as a group, and then treat other as another group. So these names are just descriptive for my own use. And again, every line of data that uses this stimuli will have all the little cells afterwards. We'll not talk about shuffle 2 yet because that is even more interesting. So we should have now is a study that looks at one of these dogs, right? Because it's going to say, show me whatever in 2, because these are all treated as a group. So they're all going to be moved around. So all we know is for sure that 2 is going to be a dog, because the dog is going to move in place, and the rest are just going to be something else. So even though our file right now looks very ordered in that it goes from dogs to cats to mice to horses, and it's like fishes. I hate saying that word. It sounds wrong. I want to say horses. So right now it looks very ordered, and our procedure file also looks very ordered. It just goes 2, 2, 2, and then it goes in ascending order. You'll see what we actually get for the experiment is not so ordered, although it does follow the constraints that we sort of understood are going to happen here, that these 2 are all going to be a dog. We don't know which dog, but we know it will be the same dog 3 times in a row, and the rest are going to be from every other category, although not following the category structure that the file has, because we're randomly moving those about. So I'm saving these 2 files. As you can tell, I obsessively save because I hate running things and have them not reflect my changes. Oh, if you ever get to this, I guess it's good to point to people. What I'm doing every time is I'm just deleting. I'm going back to the folder where it started. If I just go back to the home page, it launches back to logging in. Some random username. Again, we've only been messing with condition 13. I hit login. Question, yes. So we get a dog Lassie, dog Lassie, dog Lassie, a cat, a mouse, superhero, a cat again. So you can see it's following the constraints we set up. We basically said shuffle our stimuli, and then this is how it goes. So that makes sense. I like the examples I use. Mr. Ed. I wasn't really tired when I was doing this. Okay, so the study's going to keep running. Actually, it's over. It's very short. We go back to the login page. So as Courtney was saying, so this is starting to get more useful, right? Like this is sort of the kind of stuff we want to do. We want to be able to say, randomize this stuff for me, but follow some constraints that I want to use. And what we can do is take this a step further. Should I turn this off? So how should we show procedure shuffling? What's a good way to, let's see.
Just have the first half study trials, the second half test trials, but then just
Okay, there we go. Great job, Courtney. So we're going to go back to our old way of we're going to study all 20. Clear formatting. Cell styles, normal. There we go. So what's happening now is I'm going to show you how you can also apply shuffling to the procedure file to get, again, more interesting results than what we've seen before. No fill. So right now the study is set up to, let's say we'll treat these all as one big group. So no, this is fine. So we have 2, 3, 4, 5, 6. So we're going to go through everything. Let's see, we'll study one of these dogs 3 times for some reason. So we'll study the dog 3 times, which you know these are going to shuffle in place. And for the rest of the trials, what we want to do is study half of them as study trials and half as test trials. So we can say test. So study test. Copy this. Study test. Study. Whoa, we skipped one. Study test. Study test. Study test. So if we run this, what's going to happen is, we'll see it really quickly. So I'll show it in the files again. It makes more sense. So we're going to study 3 things the same. We don't know which dog, again, because of the way they're shuffling, but we know it's going to be a dog studied 3 times in a row. And then for the rest of the study, we're going to alternate between studying an item and then testing an item. So again, we're randomly mixing the order, but we'll see we're changing the trial types. And then I'll show you how to do this way more efficiently. So doggle yeller, doggle yeller, doggle yeller. Study a test. So this is how the whole thing's going to go. So this is the basic idea, but there's a lot better way to do this. Because right now we have a set condition, right? We see a study, then we see a test. But if we just want to know that half of them are studied and half of them are tested, we don't want to have this deterministic switching back and forth between study and test. So we can apply shuffling to our procedure file. So I'll show you the columns I've been hiding here. So the procedure file also has a shuffle column, which has been set to off this whole time because we wanted a deterministic order. But if we don't want that, we can just say How many studies are here? Let's call this 4 so we can clear the formatting there. So we know we're going to study this one thing twice, and then we have a remaining 18 trials, right? How many trials are here? I guess I can count.
17?
There's 17? Okay, so I'm going to delete one so it can be split evenly. So now there's 16 trials that are half study, half test right now, but we're going to do this the smarter way. We're going to say, okay, give me 1, 2, 3, 4, 5, 6, 7, 8. So there's 8 studies, 8 tests. And we don't care what ordering the studies and tests come in. We just want to know that half are studied, half are test. So we want to randomize these. So if we go to shuffle, we can just treat all these as, manip or whatever the code name is you want to use. All that matters is that it's the same name all the way down. So now I have a very ordered input. So I see, okay, study the first half as study, do the other half as test items. But it's getting more and more randomized for us because we don't actually know what items are coming 4 through 11, right? They're all going to be randomly selected because of the shuffling we're doing on the stimuli. The same with 12 through 19. So we don't know which items are going to end up studied and which items are going to end up tested. And this will change for every participant. So the first person who logs in is not going to get the same set of items in the study set as the test set as the second participant because this is per login. Every login, it does this shuffling one time on each file. And because we treated all these as a big group, we also don't know the order in which they're going to show up. We just know that over this 16 trial run, there will be 8 study trials, there will be 8 test trials, and they'll be all mixed in together, and items will be randomly assigned to each of those 2 conditions. So this is getting towards more like what we actually want to do with experiments. So you can see I log in here. I type some username, condition 13, hit login. So again, we're going to see the first 2 are going to be a dog, and then from then on, it's crazy. So dog lassie. There's a horse. There's another horse. There's a cow. Again, if things ever look grouped, it's because our brain likes to think that we're seeing non-random. Human brains think random is not random enough. They like to see switching and believe that's random. This is random. So there we go. So that's a quick sort of how you combine these ideas to start doing more interesting things. And it gets better when we take into account shuffle 2, which I'm going to do now. So I'm going to reset that file to how I had it originally. Reset the file. I guess I should make a point about how shuffles work. Okay, I'll do that now. It's been very quiet in here. I'm not sure if that's learning or the sound of like, oh no. Can't tell the difference.
We're very vocal.
Okay, so
Yeah, I think this part is pretty straightforward.
Yeah. I think this is the stuff that people.
This is
I think the basics make sense. Yeah.
I'm totally lost.
It's like half of this is my code, and I don't know what's happening.
We're all set.
Okay, let's see. Let me zero this out. But I think this is stuff most people need to know. Like for 9% of the stuff you want to do, this is like, oh yeah, I want to study 10 things and do another 10 with this, or whatever trial type you generate. So shuffle 2. I guess I should even make a point about shuffling. The shuffles don't care what the names are. It's not a smart shuffle. So these are called dogs. These are called. So if you look, I was saying, okay, it treats these as the same, right? These are dog. It says this is a group. So I color code them just for your, the way the computer's thinking about it. So that's a group. Oh, it's switched. These are now called cats. That's a different group. This is called mice. That's a different group. But actually, if I call this dogs, actually, just type it in. So if I said dogs right here, all the computer knows is it changed, and now it's something. So this dogs group doesn't get treated as part of the other dogs group. It's just another grouping. So if you write dogs up here and then dogs down here, the computer doesn't say these are related to each other. It just says as long as they're in sequence with the same name, they are a group. And then these are in sequence with the name, they're a group. These are in sequence with the name, that's another group. So it doesn't say relate these 2 groups to one another. So you can literally just, I've seen people do this, they just call this group 1, and they call this group 2, and they call this group, they call this group 1 again. So if you alternate, it would treat each of these as sets of 3 items. It doesn't know that the number 1 is related to the other number 1, which is a very important point to make, because I think lots of people miss that point. But yeah, don't assume that the computer's doing something smart. It's not doing anything smart. The shuffle is like the dumbest shuffle I could have written. It's literally just looking at this column and saying, if the next column has the same name as the last column, then keep treating them as if they belong together. As soon as the name switches, so basically it says, okay, I'm dogs, there's been no group before me, so I'm the first group. This next one, it says, okay, dogs again. It still goes to the first group. Dogs again, still first group. This one says, not dogs, I'm a new group. Okay, same as last time, not cats, I'm a new group. So that's a good thing, I think, to point out, because I think lots of people get confused and they say, oh, I'm treating these, I wrote dogs here, and I wrote dogs at the top and then dogs at the bottom, but they're not shuffling between. It doesn't shuffle between. It doesn't know. It just treats them as things are switching or not switching. That's all it knows. So the next thing I want to show you is shuffle 2, which is it sort of treats like a hierarchy.
And these distinctions are really specific. If you have like a trailing space afterwards or a different casing, the program will think it's a different type of shuffle. So
yeah, so
cat space is different from cat.
Yeah, so if this is cat space, it would group just the same way. So it would say, oh, this third one here is a different group than the one above it, because that trailing space at the end.
What about capitalization?
Also different.
Also different?
Yeah, it treats caps as different. That's the one type. So the reason we treat caps as different is because of shuffle 2, basically. Is the reason I treat caps as different. I'll show you why. So far we've just been saying this is a group of 3, keep them together. This is a group of 3, keep them together, but shuffle within. You can also set shuffling to off, which means don't mess with these. So for some reason you want to randomly choose a dog, but let's say in here you don't want these to be random. You want to know that when you call 5, it is always Garfield. When you call 6, it's always Felix. 7's always Scratchy. You can set the shuffle to off, and that'll tell the program, these are grouped together, but these should not be mixed up. So keep them, they belong together, but don't mix them. Keep them the same. So you can alternate between, for some reason you want to alternate between, I want to shuffle the dogs, not the cats. I want to shuffle the mice, not the horses. You can treat it that way. But the more interesting thing is shuffle 2, it's basically the same idea but pushed out to the next level. So in shuffle 2, it looks for all the things that share the same name. So these are all house animals, at least that's how I group them. So I call them all house. Again, the name doesn't matter. I mean, it can be anything. It just, as long as it's not changing, it says, okay, all these things are part of a bigger group, so a higher order group. So there's all these house animals. And then there's barn animals. So we've got, horses, whatever. I'm going to run out of Excel colors. I'm just go real gaudy with orange.
Gross.
And sort of like a fuchsia that I can really, horrible red. Okay, so these are, again, the way the groups are moving, you guys get the idea. So the higher order group, what it's saying is, okay, all of these items, 2 through 10, belong together. They're all house animals. But I want you to shuffle the blocks beneath. So now it'll, instead of 2 always being a dog, we don't actually know what 2 is anymore. 2, so this group of 3 here could shuffle up to the top, because we're saying treat all these house animals as a higher order, and now mix up the blocks beneath it. So there's 3 blocks here. There's a block of dogs, a block of cats, and then a block of mice, which I call dogs. But the program basically doesn't care. Would treat it the same if that was written as dogs as well. So all we know now is we're trying to break the association of this number means this thing. When you're thinking about, in conditions, let's say we just want to see, do people remember house animals better than they remember barn animals? Let's say that's the study we want to run. We want to say, okay, we think house animals are more memorable than barn animals, but we don't want to have to set which house animal. We're saying we've got a pool of different house animals, and we want to randomly compare one item or a house animal against a barn animal, and that's the study we want to run. So if we use shuffle 2, what that says is these blocks, these shuffle 1 blocks, all belong to a higher group, which is called house. And now house goes and it moves the blocks around, so dogs can end up in the second block or the third block, mice can end up in the first. So those 3 are shuffling. And also, because dogs is a shuffle group. The items of dog are treated as they're shuffled wherever they end up. I'm trying to think. I can show you how to do this with, again, random numbers. Okay. So I think the random number thing is the easiest way to understand how the program thinks. So I'm doing is saying, give each grouping here the same random number. So,
my parking is up.
oh, that's fine. I mean, it should be on the internet in theory. You can get home and probably catch up to where we're at right now. So you can see I set a random number for each group, and I say, okay, the next two items share the same random number. In effect, what this is going to do is, if I shuffle items 2 through 10 by the random number they get, they should stay together, if Excel is nice to me. Which is essentially what the program does. It says, okay, house, these are all belong together. So the items 2 through 10 will be the house groups. But we don't want to know which order the house groups are showing up in. Boom, it worked. So see, before it was dog, cat, mouse. Now it's mouse, cat, dog. The next person logs in. So this is a way to sample to say we don't want to know which specific cat we're looking at or which specific house animal. We just want a house animal. Give me a category of house animals, and I want to compare that against a category of barn animals. So I could just say, let's say I want to study, it doesn't really matter which one it's going to be randomized. So I want to study 2, then 3, then 4, which are, so what would 2, 3, 4 be? Which items are those? What can we know is going to happen? If I set 2, 3, 4 to be studied, and then I'm going to set 11 and 12 to be studied. Let's say that's our whole thing. What's the study?
3 cats? No. Let's see. What's the smallest number? 3 mouse?
Well, so you're looking.
I'm looking at the randomized numbers. So whichever one that's the smallest is going to get called first.
Oh yeah, you're taking it a step further. You're already doing the shuffling in your head.
Oh.
No, that's good. I mean, yeah. So you're right. It ends up being 3 mouse, and then the random numbers generate again. But what's important here is that we don't. If for each participant who runs it, all we know is that we're going to compare one group of house animals against one group of barn animals, right? Because these barn animals are going to go through the same process, and that. So again, I'm just doing where I say, okay, give me a random number for this group, and then make the next item the same random number. So in Excel sorts these, which is essentially how the program thinks about the shuffle 2. It says, oh no, headers, column G. So now cow and horse flipped. So all we know is we're going to compare one of these house animal categories against one of these barn animal categories. And take it further to make it more realistic, we can say also 2, 3, 4, oops, 11, 12. Because if you want to run a real study, it's pointless to just have study events, right? We want data. So we're going to test them afterwards on their ability to remember the animals we showed them. Timing, we'll give them user time, so we want to let them take as long as they'd like in the study or in the test. At the end, should be a relatively easy test. We'll leave post-trial to no because we're not there yet.
It could actually be a really hard test because it's under specified cues.
Yes. Is it? Well, no,
it's
study.
just cat. I mean, you could just put in one of the cats. You wouldn't necessarily put the cats in the correct order that's being scored.
Oh, that's true. Yeah. So yes, this would be a problem for lots of reasons.
But usually you don't have like the same cues with different targets. Like that's just not how you would set it up.
Yeah.
But it works here for an example.
Yeah, usually we'd have a bunch of different cues, bunch of different targets. So procedure notes. This is actually a good point. Notes I like to use just for coding data myself. So I'll call this study trials, and these are test trials. Or if you have the test broken up, you can do lots of ways to break up the test. So study trials, test trials, shuffling here. We're going to leave it off for now, so we're not going to shuffle our procedure. And again, we're moving more and more towards like a real type study. So what we're going to do is we're going to study 3 animal or 3 of the house animals. We don't know which house animal. We're going to study each of the 3 of them because we're not repeating 2. It's 2, 3, 4. So different things will end up in 2 and 3 and 4, and then 11 and 12. So we're either going to get cows or horses. Does horses sound wrong to anyone else? I don't like it.
Well, horsey definitely sounds wrong.
Feels right in your horses.
Sounds way better.
Horses feels right in your heart, though. Horses. It's ugly.
The manly word is so horses.
I know. So horsies. Okay, so sorry, it keeps going. No, you're gonna keep you. Okay, so we got mouse. We got each of them. We got Mr. Ed and Seabiscuit. That's exciting. So now we're testing on mouse, like Courtney said. Who knows which one? So we'll guess blindly, Minnie Mouse. And see, these aren't going at a pace because these are user timed. So I can sit here essentially forever and try to decide if it's Mickey or Minnie.
Is it possible to set a maximum time so if they spend too long, it will automatically move on?
Yes, and I'll show you that. Computer is technically a maximum. Actually, we don't have max timing, right? We can set computer and then user, right?
For what? I haven't been following at all.
you set timing as computer and then you set min time as user, which is effectively is a maximum time, right?
Yes. So timing is the max time, and then if you don't have a min time, it's
Which we haven't talked about.
assumed to be the same as the max time.
Okay.
Yeah.
But then you can specify a min time.
Yeah, you can specify a min time that's shorter, so that's like, okay, the max time is 4 seconds, but I'll let them submit after 2.
Yeah, so actually we can do the same thing right here. So here's Mickey, and then we guess again, and then I don't know which horse we're talking about or that one. I'm really bad at this test.
So could you set your min time to user and your max time to a maximum time?
Yeah.
User is assumed to be 0.
But with a user time trial on your system, how do you have a minimum and a maximum?
What do you mean?
So if I
So you set min time as user.
But I don't want people to I don't want them just to type willy-nilly. Like, I want them to spend at least 5 seconds thinking about their response.
Okay, so
But I don't want them
min
to
time
spend...
of 5, max time of user, or timing of user. That means after 5 seconds, let them submit at any time.
However, what if I also want to put a max on that?
Okay, so
min
I can
time
show you.
5, max time 12. That means wait until 5, give them the option, force them to go after 12.
So I'll show you in the file. So watch. Look at the files we're looking at. Wait, I'll show you.
No,
So
but
look at the
because
files.
it's maximum, it assumes.
It is.
Yeah.
Okay, cool.
So what
the
we've
only
been
option is that it's user time.
Yeah, so far I've only shown you timing, which is effectively, like Tyson said, it's a maximum time. If it's user, that means there's no maximum. They can do it whenever they want. If it's whatever the value is, or if you give me a number like 6, that means you have to be there for 6 seconds. But if I add a column called min time. So for the studies, I don't want to have minimum time. I want to force them to stay, so I'll just put a little dash there. As long as min time isn't a number, it won't be enforced. I believe, right, Tyson?
Yeah.
Okay, so max time. So now, let's say we're doing the same study. They're going to study everything for 1 second, and yeah, we'll do one step at a time. So they're going to study everything for 1 second. So timing is 1 for the study part. When they get to the test, we want to cap them. They have 10 seconds. So usually, if it's just 10 here, that is saying they have to do it for 10 seconds. But if you add a minimum time, 10 basically becomes, after you've exceeded the minimum, then you have the option to submit. Mm-hmm. So here, if I set a minimum timing of 5, so I want them to try for at least 5 seconds, it said max is 15. Oh, no, 10, because 15 will be annoying to wait for.
We just click submit.
Yeah. But when I show them how it maxes them. So under this case, we're doing the same studies we did last time. Now they have up to 10 seconds to respond. If they take longer than 10 seconds, the program will manually push forward. But after 5 seconds, they have the option to submit. So if they're done typing, they hit submit, and it's good to go. So I type some junk in. Again, I nervously save my files again. It's like such a bad habit. I hit Control S on things that aren't even, I'm not even working on them. Like I'm on Reddit and I'm hitting Control S. It's like
You're saving all of your random numbers.
Yeah, my hand has got like a learned response to hit Control S whenever I'm not thinking. So I log in, same study, they're really quick, boring. We got mouse again, randomly. We got cow this time instead of horse. So I can't submit yet because it's not 5 seconds, but if I type mini, okay, so it's been 5 seconds, so I hit go. Here I can type and I can't submit. I'm hitting enter as hard as I can, it won't go. Can't click the button. It's 5 seconds, let's pretend I'm still thinking. So I'm still not sure about my answer. Oh, there we go, I hit 10 seconds, it forced me.
Does it record whatever they have?
Yeah, so when I hit the submit button, it gives you, in the data, it'll say response, and our RT, which is the reaction time or response time, and that will be down to the milliseconds when they hit the button. So if you see and the value is at the max, that means they basically ran out of time typing, or
Right.
it will be within 2 or 3 milliseconds of the max, because browsers aren't very great at controlling timing. So that's min timing. Min timing is really useful. And the other thing I was going to show, oh well, I went to the code folder. There we go. Was, again, if we want to make this more like a real study, you wouldn't study all 3 mice together and then all the 2 other animals. So you just say, okay, these are, let's just call these study. Actually, it doesn't matter what we call them, but so you could do this. You can say, I know the first 6 are up to column 6. I want those grouped, and that would be treated as a group. And this would be, well, let's make it shorter. Let's say that's a different group if I just copy and paste them. The program would run the same, but this is bad practice. It's good practice to actually have descriptive names for your shuffle, so I tend to call this study phase. Because again, each one of these cells is going to be on every line. So every line that is row 2 will have all the little notes you make for yourself. So you save yourself a lot of time in data analysis if you think ahead of what type of stuff would I want to use later. So these are all study phase, these are test phase. Because especially when you start using pivot tables, you can say filter by study phase items, and it'll drop all the items that aren't in the study phase for you if you do this stuff ahead of time.
So in your stimuli file, you have shuffle, and then you have shuffle 2. But in the procedures, there's only shuffle.
No, there's
shuffle 2.
You can also do shuffle 2 there. Okay, just
yeah. So shuffle. For the group. That's a good point. So most of these files, if you don't want shuffle 2, you can just delete that column, and it goes. The functionality just assumes don't use it. If you want shuffle 2, you just make a column called shuffle 2, and then you can start using it. So for some reason, I wanted for half of these people the study phase to be before, or the test phase to be before the study phase. So we're doing precog, Daryl Bim, feeling of the future. So this is the study we want to run for some reason. We want this to happen, so I added shuffle 2. I'm saying shuffle all of these, and I run this study. What we'll get is this. I didn't obsessively save, so if it worked. So yeah, so now I'm starting with the test because I added shuffle 2 and said there was a study phase, there was a test phase, but mix up when those appear. So for some reason I wanted this, I could do it. I don't want it.
And that's another
Yes.
annoying shuffle one for the group.
No, shuffle's good. This is stuff people were most confused about last time because I didn't explain it.
In your stimuli file, so we have dogs, we have cats, we have mice.
Yes.
So you already told us how to like mix up, the dogs and the cats and the mice, kind of like completely, or just put the mice first and the dogs, so like move the blocks around. But what if I want to keep the order within dogs constant?
Okay.
Does the off functionality still work if you want it for all 3? Does you have like the case sensitivity there?
Yeah. So I want to move mice, cats, and dogs around, but I want to keep Mickey, then Itchy, then Minnie,
exactly.
Garfield, and Felix, and Scratchy. So this is the thing I was telling KP earlier. The reason it's case sensitive is that the program just looks for any case version of the string off to determine if when shuffle doesn't work, look at any case of off. But to group them, it's sensitive to the casing. So what that means is you have to basically do this to get what Courtney wants. If I want the mice to be treated as a group, but to not shuffle within their groups, so I want the program to say move mice, cats, and dogs around in blocks, but don't disrupt the order within the blocks. I'd say off, which means don't shuffle these, right? Like we were saying earlier, don't shuffle the mice. But the problem is if I kept just writing off the whole way down, it wouldn't know that cats are a group. So I can just say off with a weird casing. So off lowercase is now treated as that's a group. And then I can say off with a capital O, capital F, lowercase f. That's a different group. So this is essentially why we had to have that weird workaround that some stuff is case sensitive, some stuff's not. So this functionality, I basically wrote the shuffles and realized I wanted to do this sometimes. So I added a line that would say, if the case of the first shuffle line is different, don't then group them. If the case changes, assume it's a different group. So which is why you have to be careful. So if you write, say, dog, oh, that's mouse actually. So again, you could, so let's say, I did have mice. I had mice before. So you have mice and then M, oh there, perfect. The program would say, we have one mice, oh, grammatically that feels bad on my tongue. So we have one mice, call that a thing, and then we have, oh, it switched, the case changed, this is the new group. So this is effectively how the program would treat these things. So you have to be very careful of your shuffles. The best way to do it is to type one of them, copy it, and then paste it to all the other adjacent ones. Because if you do mess up and for some reason the casing changes within a group, the program will pretend like it's a different, or it thinks it's another group. Again, it's very dumb. It doesn't know anything. But you guys are smart, so you take advantage of the dumb things it does. It's predictably dumb. Yeah, so what were we talking about? My brain turned off.
We had just finished with like shuffling, like the shuffling too.
Okay, so should I show you guys post trials? Because I think that's the stuff that people care about who are in. So far,
Before that,
KP.
sorry, before that, so
Okay.
let's say we get rid of shuffle 2 in the procedures.
Oh, procedure?
Yeah, let's
Okay.
say we get rid of that.
Okay, I deleted
What's
it.
going to be the functionality here? Just to make sure that it's clear.
So you tell me what it is, and I'll.
Okay, so it's gonna mix all of the study phase ones. It's gonna be random from there. Hang on, what do you have now in the items?
Sure.
Top 5. Okay, so it's gonna be a group of either maybe 3 mice trials, and then no. Oh, will it? I'm confused.
You're
It
close.
It shouldn't, right? Because now it's mixing up all the study trials.
Well, yeah. So we don't know. The 3 mice aren't going to come together anymore, right? They're going to be mixed in with. Also, they're not going to be mice necessarily, because 2, 3, 4 just points at
Right,
these
so
lines.
yeah, assuming that those are gonna be.
Yeah, assuming mice
priority.
end up in that
Right.
position, then it will be 3 mice mixed in with 2. In this case, if the shuffle ended this way, 2 cows,
Okay, I see.
but they'd all be intermixed, so you
Okay.
wouldn't see a
So
block
they
of
would just
mice.
be like mice, cow, mice, cow,
Yeah.
whatever. Okay.
And then the test would also be randomized. It would basically the test is just going to randomly test all the items we saw.
Okay.
In no particular order. So I can just run it. I mean, it should take like half a second as long as I've obsessively saved as I do.
Okay, so it's gonna be dogs and whatever.
So we, and then again, poorly specified. Yeah, so it's randomly selecting one from the house group. And we could even say, let's say we want to do it differently. Let's say we want to study one of each of the items from the house group. So instead of studying all mice, we can say I want to study 1 mouse, 1 cat, and 1 dog. What we know is that items 2 through 4 are going to be a group. Item 5 is going to be a different group than item 2. Item 8 is going to be a different group than item 5. So this way we'll get 1 from each of the categories.
Mm-hmm.
We don't know which one, right? Because the actually, which one do we know we're going to get? Of the house animals, which animals can we say for sure they're going to study?
Mouse.
No, it's a mouse is randomized because if you look at the shuffle column, we mix up the mouse group, so we don't know which mouse we're going to get.
Oh,
But the other ones.
Okay, so it's gonna be either the cat or the dog.
So look at shuffle. Shuffle will tell you what's going to happen within the blocks. So yeah, this is actually pretty good.
Oh, I see. So it's gonna be either the cat Garfield or the first one of the dog. Oh yeah.
Yeah. So those two are going. Every time somebody runs a study, they're going to see Garfield and Old Yeller, because we're not mixing up those blocks. So we just know we're sampling the first from each block. But because of our turning off the shuffling in the cat block and the dog block, that effectively means we're only ever going to see one of the cats and one of the dogs.
Okay.
And a good thing to notice too is when you do shuffle 2, make sure the groups are of equal size, because this is the problem you run into. So let's pretend we have a group of 3, and let's pretend these are all like pets. So as we have mice and then we have pets. The problem becomes we don't know which. So as is, if we were shuffling these, we don't know if 4 and 5 are going to be in the same group or different groups, right? Because if we move this block of 6 to the front above the mice, then items. Actually, I'll just do this because that's easier to show. So I'm just setting each of these equal to. I'm basically just giving all these the same shuffle code. So I'm saying all the pets share the same shuffle code, so they'll all end up in the same place. So when your groups aren't equal sized under a certain shuffle 2, this can happen. So right now, we know if we say item 4 and item 5, we're going to get one item from the mice group, one item from the pet group. If we shuffle like this, do it again. Come on, give me a different. Here we go. Now items 4 and 5 are both in the pets group. So because the groups aren't equal size, when you shift them around, we can't know for sure if 4 and 5 are of the same type or of different types. So just be aware that when you're doing this type of shuffling, if the groups aren't equal sizes, it becomes unpredictable what's going to end up in position 4 or 5 or in those boundaries between the groups. So again, yeah.
But that function still can be very useful even with groups of unequal sizes. You just have to know, like when you're looking at your procedures file,
Yeah.
It doesn't
what to
break
expect there.
anything. It's just
Right. And if you're just going to have like a huge long study phase without all the items, it doesn't matter at all.
It's more of a problem for repetitions.
Mm-hmm.
So if you want to repeat, or not for repetition, if you want to say, I want to say 2 items of the same type, if the groups aren't equal sizes, it's hard to say that, oh, items 4 and 5 are the same type. Let's say you want to do a study about studying, related items versus unrelated items. It's harder when you don't have equal size groups now, because we don't know which items are always going to be the same type. Where before, when there were three little groups, we knew 2, 3, and 4 are always the same. 5, 6, and 7 are always the same type. 8, 9, and 10 are always the same type. I don't know what I did there, but I can fix it. Okay, so what should we show? Should we show post stuff, which is I think the stuff people care about? You have done this before.
Yeah.
So I'm going to reset this all back to whatever it used to be. And I love Git extensions. Refresh, go back. So far I've shown you just trial types, which there are basically 3 things that almost every trial type can take, which is for every trial type you need to say, here's what type of display, so what trial type are we using, the timing, how long do you want to see it, and then optionally is the minimum timing if you want to set, like, after this many seconds they have the option to proceed. And that is still true for the next thing I'm going to show you, but it's a little bit different. Where did we go? It's test stim shuffle, is that? Forget every time? Yeah, there we go. So this is less dependent on what's happening over here, but more dependent on what's happening on the other one. Okay, so now let's say you have a study where instead of just, so we'll go back to the case of, it was 219 or 220, right? We want to study everything again. Everything for 1 second. Delete minimum time for now. Okay, so now we'll get into the post-trial stuff. And shuffle, we'll just leave everything off for right now. So let's say you want to have a study now where you want to study an item, then test an item. So earlier we did that, right, where we did 2, 2, and we alternated between the first 2 was a study, the second 2 was a test. But that gets annoying when you want to shuffle all of those groups. So let's say you want to move, instead of just 2 always coming first, you want 3 to come first. So the easier way to achieve this is to use a post-trial, which means after each So we do we go to 2, and we do the trial type study, which means look at dog, old yeller, or whatever happens to end up in that shuffle position. Do a study trial. The timing will be 1 second, so we study for 1 second. And now instead of having to say, okay, now we want to see the same thing again and do a test, we can use a post-trial, because we'd have to, you imagine we'd have to do that for every of these 20 items. You have to say, now do that item again and then do it as a test. Instead, we can use a post-trial. So post, the format here is you write the word post, then a space, and then the number. So you can have unlimited post-trials, but for now we'll just show you post 1, which means after every study event, do this event, or wherever we set. So right now, these have all been set to no, which means don't do anything. There's no post-trials. You could also just delete these post-trial columns if you weren't using them, and it would just simplify your file, but I left them in there so I didn't have to type them again. So now what we want to do is we say we want to have a study where we study, then test after every single item. So we set the post 1 trial type to test. So anything that could have been a trial type can also be a post-trial type. You just use the same trial files. You say, okay, I want to do a study, then I want to do a test. Or you can say I want to do a study and I want to do a copy. So we can imagine we want to do half study, half copy. This is probably not half, but I'm going to guess half of these are going to get copies. And then the posts are just like the regular trial types. They need the same parameters, so they need a timing value, and they need min timing, or they don't need. If you want, you can have a min timing. So the post timing, let's say we want to give them user control on all the tests. So they can go as long as they want. So now we have a trial type, which is study. The timing is 1 second. Then after every study trial, use that same stimuli we referenced before on this line, and now apply it in a new way. So the new way here is we're going to do it as a test or as a copy for the other half. And the timing on the post-trial is we're setting it as user in this case. The notes, we can just leave them as random gibberish for now. Actually, no, gibberish looks ugly. Oh, dash, that looks pretty. I think they can be blank too, but I hate having blanks in my files. So now I should be able to just go in. So I haven't tested all this stuff yet, but this should work in theory. It's just all Tyson's work. Working to achieve the same goal in the end, but in a more stringent way. Okay, so I hit login, and essentially I'm just going to run through all the items. Let's see, how is the shuffling set up? Yeah, let's actually talk about that. So right now I'm not shuffling the procedure file at all, so I'm just going to go 2 through 20. But because of the way the stimuli are shuffled, all I know is that I'm going to see all the house animals first, then all the barn animals. Each species of animal is going to be grouped, so the dog's going to come in a sequence, and then the cats and the mice, and the horse and the cow. But we don't know within that sequence what ordering they're going to show up in. We just know it's going to be house first, then barn after. And at the very end, the items aren't shuffled at all, so we know the last are going to be Doctor Who, Dr. Dre, Batman, Superman, Hulk, Wolverine, because these aren't shuffled at all. So that's deterministic, at least from the way it's set up now. And every trial is going to be a study, followed by a test for the first half, and then a study followed by a copy for the second half, I believe. Let's see, go experiment. Cat scratchy. So that's the post trial. So we're still on whatever that first line is. Oh, it's user. I have to type. Oh no, I have to type on all these. So Garfield. I'm just gonna. So I'm a bad participant. I'm just. Oh yep. This is why you don't just set user time as well. This is why you want a min time, because you can have a participant who just does this. I mean, it'll show up in your data. You'll see fast response times and no responses, but I like to punish them if they're not going to try. So now we're going to see study test, and then at one point it's going to switch over to copy. So there's the copy trial, so I just failed to copy.
These are super useful for JWALs.
Oh yeah, I haven't said that, but we have a JWAL trial type. So
which is like where you would want this type of construction.
Yeah, so the reason we did this originally is that for people who do memory stuff, if you want to have item by item JOLs, it was really annoying before because you had to say, okay, show me item 2 and then do item 2 as a JOL trial type, and then you had to later put the stuff back together. This way you can say, okay, show me item, and also what's really nice is that it keeps the data on the same line, so it makes it very easy to say, correlate their score with their JOLs and give me a gamma correlation, because that data is all on the same line. So for trial 2, we have, if they got it right, when you test them and you say you give them a test and ask for a JOL, or after JOL then give them a test, you can just say, okay, correlate those two things, and it's super easy. Where when they were broken up across different lines, it made it really hard to go back in your data, not hard, but annoying to go back in your data and try to put the things back together. This way, it's really useful when you want to keep all these data points on the same line because you want to make comparisons.
Can you force them to type something before clicking submit?
No, but we can
Not
probably
yet.
add that. So in a day or two, Tyson's going to add a thing that will force them on. Right now, there's, I guess we'll show
Day
you.
or two. That's a lot of pressure.
Well, I think it's already written, isn't it?
Oh,
Mostly.
yes.
Okay, so here we'll show the thing Courtney wanted to show, which I think is the useful thing. So JOL is one of the trial types, which is a judgment of learning, if you're not familiar with it. But we want to have them study a thing and then say, what's your chance of remembering it? So here the only changes are to the procedure file. So we're saying, study it, then make a judgment of learning after every trial. We can even time them. We can say you have 5 seconds. So you want to give them, you have to make a speeded judgment of learning. However speeded you think that is. You have 5 seconds. And we'll just copy this all the way down. Everyone's going to do study JOL, and everyone will have 5 seconds. Or if for some reason, no, let's not overcomplicate things. So now they go in here, they log in, condition 13, yes, study. How likely to recall this on a later test? 100, I'm really smart. Itchy, how likely are to recall this? 50. So this is if you want to do item by item. If you want to just probe them randomly, let's say you want to get, instead of disrupting them after every item, you want half of these to be JOLs, you want 5 JOLs, you say 1, 2, 3, 4, 5. The rest of these, I don't want to do anything. I just want to have them study and move on. And again, we don't want to have it, these are the only 5 items that get JOLs, because those would always be some barnyard animals. So we just say shuffle everything, just call it all mix, or whatever we want to call it. We just say, within this study, all we want to know is that they study all of these items. 5 of them they give JOLs, the other 15 they don't, and randomize pretty much everything else for us. Click something, 13, log in. So I'm studying, how likely, 40.
Why does it do that? It's asking you a JOL right after instructions.
Oh, so wait, you mean, wait, you didn't see the study trial?
Oh, maybe.
Oh, maybe it was a weird lag
Okay.
thing. But yeah, it should have, on my screen it showed study and then JOL. So here's the part right now, they can type this. Tyson's going to add a thing in a day or two that will make them type numbers, because they could just write like hi in the JOL.
And then probably I will also add something so that their number has to be within a certain range, like they can't type 900,000.
Yeah. So again, it's all randomly mixed. Again, every participant who logs in is going to get a new random mix of stuff. So as you combine lots of this random mixing with kind of setting these files up the way you want them, you basically can make almost any experiment you want. It's pretty easy. As you can see, we have done no programming. Like literally, we've been looking at Excel files, which I think I created this way because 1, Nate Cornell was doing it this way, and I stopped Momentum. And 2, I think grad students spend all day looking at Excel sheets, so we're good at Excel. So this is the easiest way I can think of, like keeping the experiment together in your head. Just pull up 2 Excel sheets, look at them side by side, and say, okay, I want to see this and this. I want these to mix together. I want these to mix together. I want to see these items in this way, see these other items in another way. And so we've accomplished all of this without any coding. But there is some stuff you want to mess with in the code. So most of the things you'd want to mess with, so again, they're in the experiment folder. There's this file called settings.php. Open it in Aptana, because I like Aptana. So this just sets lots of stuff we'd want to look at. So Again, this is mostly not coding because I pulled out all the things that you usually want to mess with and put them in one file where you just change the string names. So experiment name, most people tend to leave it as collector, but I would highly advise you don't do that because this is really useful for, again, you go back and you find data you collected 6 months ago and you're trying to even figure out what this experiment, like which experiment is this? And this is a really good way, like, you make a change, you're like, okay, whatever, project name, revision 1, and you run it online, and then you make some notes. You realize like, oh, this didn't work well. I need to change this aspect. Revision 2, and now you have an easy way to find this data anytime later and kind of reconstruct why you made this experiment or what you were doing or which data set this even is. So you just change it in rev 1, save. So now every line of data this experiment creates will have that experiment name on it. So anytime if you find this data, you can reconstruct what's going on. Login counter name, the only reason this is really here is that if for some reason you get into the study and you realize you want to just restart the cycling of conditions, let's say you're on condition, there's 12 conditions, you have people collected for conditions 1 through 5, you find a mistake in the program, and you realize like, oh, it's not doing what I want it to do. Fix the file, I would change the experiment name on it so you can separate those data, and then change the login counter to like login counter 2, so we'll start again at condition 1 and start running again. Do demographics, so I haven't shown you this, but if you set it to true, so it's been false, but at the beginning, you actually have the ability to collect some demographic information, like a standard set we do, so just log into 13. So it goes here immediately before the instructions, so gender, age, education level, fluent in English, not fluent in English, what country. This is all useful, especially on Amazon Mechanical Turk. We have here the informed consent. So you can write whatever text you want here. I'll show you later where to mess with this stuff. And then at the end, you hit submit. It saves all the data. That stuff gets recorded when you pull out your output. Thanks to Tyson's get data. Next experiment, this is really useful for chaining experiments. Let's say you want a participant to log in one time, and you have a 5-minute study, and you have another person who's doing another collector study, and there's this 10 minutes. Or let's say you have a half-hour study, and you don't want to have the participant leave after half an hour. You want to have them run another of your studies. You just have this linked to the main folder of the other study, and when your study ends, when it gets to the end of your study, it automatically logs them into the next one, and they get new instructions and start going. So they just see it as a multiple-part study. And again, a way for you to be much lazier as a researcher. You log them in once, or ideally your RA does it, and you sit at home and sleep. This debugging stuff, I mostly wouldn't change this unless you have issues. So check all files means it goes through, when you log in, it checks all of your files from all of your conditions to look for errors, and then it stops them if it finds errors. This is really useful, especially when you're first creating your experiment. You don't want to get, run 20 people and then realize one of your conditions doesn't work at all. Every time they log in, it breaks. So check all files will make that a lot better. Oh yeah, check current files. We'll just check the files for that condition you're logging into. So let's say you're just working on condition 4 of your new experiment. You just turn check current files to true. When you log into condition 4, it doesn't check all the other conditions, so it's technically faster, but you won't feel much of a speed difference either way. Like, the computers get most of the stuff done that's really quick. Debug name. Oh, so I can set a name. Right, Tyson? It's just, I said.
Yeah.
Let's call it.
I don't remember what it's used for, though.
So this will enter some sort of debug mode. We're not sure what it does yet.
I think currently it sets all the timings to 2 seconds, and I have a couple other debug functions.
Oh, debug time. There we go. Right under it says debug time. So let's pretend 1 second. So no matter what our study is, debug name, if I set it as a test, it's the bad debug name. When I go to log in, if I type test as my name and hit login, wait, it will break because that's not experiment, not condition 13, which is the only one that works right now. So I say test and log in.
I think I was setting up the IDs, and I was just in the area of the code that had usernames. I was like, oh, why don't I just put this in case I want to use it later?
Oh, it separates the data. That's the other thing. That's probably the bigger thing, is that when you log in using the debug name, it keeps all that data separate from the data of the participants. So if you want to run it, that's the big benefit, is you just log in under that name every time, and it separates the data from this is debug data, this is the actual participant data.
So you don't have to go in and delete
Yeah.
Like experimenter tester.
Yeah, I used to write delete as my login name so I remind myself to delete that data every time. So Tyson fixed that. So now we just say test.
There are some people who just type in whatever random things on their keyboard, but they always start with a different letter every time, and it's a different random string of letters every time, which means to go and search for those names becomes a pain in the butt.
So actually, so you look, so we had the JWALs for 5 seconds. If you look, they're actually 1 second now because we're in debug mode, and in the file, debug time is whatever I set it to, so it overrides all the timings and just makes it go really quick. So if you just want to see, does it run to the end, you can just set debug time to something really short. In theory, when we fix the decimal point time, you should be able to set it to like 0.1, and it'll just quickly cycle through the whole experience so you get an idea of like, here's the experience. Here's the ordering of the experience. You don't know the timing of the experience.
0.1 is probably the fastest if you're on the server, but if you're doing it locally, you can do like 0.01.
Actually, let's see if that fixes it. I thought I did put it in at one point. So 0.1, let's see what happens.
I thought it was part of my min time, which we did.
I think I looked at that pull request and put that part in. So demographics are done. Let's turn them off.
It was a tiny thing, just changing a parse into parse float.
Yeah, I think I saw that and fixed, or I pulled it from yours.
Cool.
So does it work? Seems to be. It just skipped like to the very end. Maybe it's not happy with that time.
Yeah, it's probably thinking it's 0.
Oh, yeah. So I didn't pull it in. Okay, maybe it's in a separate branch.
I
Well,
can-
that functionality will be there when you run it in the future. Unless you're watching live.
It
in
can
which
be
case,
up by
no.
tonight. It's a small thing.
Yeah, it's a small thing, so we'll be fixing it there. So we're kind of in transition. Trial diagnostics. I really like this. I put this in there because people would get confused about what's happening. So if you turn trial diagnostics to true, and also stop at login to true, it will show you. Well, at least stop at login to false for now. And debug, we won't log in. There's debug mode. So trial diagnostics shows you all the information the program knows about your logging in on each trial. So here, see all this information. It's going really fast right now because we have the timing set up super fast. Let's see. I'm going to change the timing so we can look at it. So instead of timing 1, we'll set it to user so we can mess with it. So trial user. So here's what trial diagnostics gives you. It's really good if you're building trials and that you can see what information is available to you. So I've set everything to user. So we see here's the display of a study trial type. But here's all the diagnostic information about the condition we're logged into. We're in condition 13. It tells us which stimuli file we're using. So this is really good when things aren't looking weird. You're like, okay, where do I find the source of this weirdness? So here's the stimuli file I'm in. Here's the procedure file I'm in. Here's the description of this condition. Here's the trial number I'm on. So if it breaks for some reason on a certain trial number, this will tell you, okay, here's the trial we're on right now. Tells you the trial type, the post-trial, the trial timing, the queue being used, the target being used, the answer. This array is basically how I run the whole thing. Like, it's saying, here's all the information I know about the current trial, or here's all the information the program has stored about the current trial. Sometimes you might get a trial that's blanked out here, and if you look at this array, and under stimuli there's nothing, you're like, okay, that's the source of the problem. The program isn't reading the stimuli file correctly. So under stimuli, you see we have the queue, the target, the answer, and if you add extra columns, those extra columns will show up here. Under the trial diagnostics, same for procedure. Here's all the procedure columns we have and each of the values that was set in that file. Under responses, these are actually all the placeholders we have waiting to store your responses. So right now they're all blank because this trial doesn't have a response yet. But once responses are stored, it'll show you what response we gave. So actually, if I progress this, oh, and then at the very end I can get crazy. So if you click on these, they slide up in a cool way. So this one, information loaded about the entire experiment. Here you can see the array that stores all the information the whole experiment has about you. So we can see trial 0 is blank because we don't have a trial 0. We started trial 1. So trial 1 is an array with stimuli. These are the stimuli that were used. Here's a procedure line that was used. Here are the responses for trial 1, trial 2, So you can go through the whole thing and see where it breaks. You can say, oh, for some reason at trial 5, there's no procedure information. Something's weird at that line of the file. You can also look at also past responses. So right now we're on the first trial. It took forever. So if we look back at the entire experiment, we can look at trial 1 and the responses, look at our response time. We were there for that many milliseconds. And if you were 100 trials in, you can look back and see all the stuff, all the responses given, all the accuracy scores, all the... So RT key is the time to the first key press. RT last is the time to the last key press. The strict accuracy, if it was scored, the lenient accuracy. The accuracy is just the number, the percent match between the thing they put and the thing that is supposed to be the answer. These post-1 just means if there was a post-trial type, here are all the responses associated with that post-trial type. So diagnostics are really good if you're having trouble. Turn these things on and just start looking around and seeing where the issue is. So turn these back off because they make the pages look weird. mTurk mode. This is literally just if you want to run a mechanical Turk, you tend to get verification code. So if you turn this on, you can set the verification. So whatever that string is, hi participant. And it'll say, you're done with this study. Your verification code is hi participant. And then you look at all the people who submitted data and see if they have the correct verification code. That lets you know they actually went through the whole experiment. Check eligibility we'll talk about later, but it's super useful. These post-trial timing values don't matter anymore because you got rid of, so these will be deleted in about a day. Here's something useful that everyone would want to mess with. Index. So index is the main page you log into on your experiment. So show condition selector. So right now I've been showing you we choose condition 13. If for some reason you don't want them to choose, or you don't want them to have the option of choosing, set it to false and refresh the page. Selector goes away. Set it back to true. Oops. And selector comes back. The experiment description, so it says it'll run for approximately 25 minutes. Your goal is to learn this information. So the stuff that's there, you can turn that off. You just say whatever. Blah. That's what it tells them. So most of the stuff is really just like finding what's in the string. So instead of UCLA, say university, email address, refresh, enter your university email address. Here's the criteria it uses for scoring. So what percent match is counted as a lenient correct? We default to 75. If you want to use a different value, change it. So say 50% match is good enough for you. Put a 50 there. Now when it scores, it'll use 50 as the value. Stop for errors, I tend to always leave on. That means at the login screen. So in condition 1, if I try to use it, I told you these are broken. So it stops. It says, hey, something's wrong with your file. If you really wanted to make it run, you could say false, which means don't stop when I get errors. And it'll keep going, but the problem is there are errors in the study that will run weird. Stuff probably won't show up, or it'll error out in other strange areas. But if you really wanted to force it, you could. What else matters? Experiment email. At the very end, it'll say, hey, if you have any questions, email me. Obviously, don't make them email me every time, please. So, yeah. I said that's good for today, right? Is that like a good primer?
One thing.
Courtney.
For the instructions, you may wonder. So if the instructions are not in, or that first set of instructions,
yes.
Those are not in your like stimuli file or anything. But you can put additional instructions trials there if you want to.
Wait.
I'm sorry, in your procedures files.
Yeah.
So like it might be opaque to people like where to go to change those initial instructions.
So I think, I forgot to even show you that. So this page here, if you open into the experiment folder, there's instructions.php, and it looks just like this. So that page, it says when you log in, it does this. So I log into the condition that works, and I get this task instructions. Mm-hmm. That is all just in instructions.php. So you can see most of it is just text. So if you want to change the text, you just type whatever you want in there. If you want to create a new paragraph, you can just copy one of these paragraphs, paste it after, and then change the text inside of it. The question you ask here is down at the bottom. So you pay close attention, so you just change this text to whatever your question is. The buttons, oh, this is actually important. So one of these buttons has class, or has ID equals correct. This is the button with the correct answer. So if they don't click this button, it tells them try again. If you want to have way more options, you can, just double the options. You can have 50 choices for them to choose. Most of the stuff is just copy pasting and changing text, at least for instructions. And I think that's everything.
You want to add another page to the instructions.
Another page is you'd have to basically loop it in or use the instruct trial, which
Well, that's just
most
for the
people do.
first one. So like at the very beginning of the experiment, that's where we only have one page, and then you do the multiple choice trial. But there's a trial type called instruct that you can put wherever you want.
Oh, I see. You
So
can
you
make that the first row
You
of
can make
your
that the
order
very first
file.
row, exactly.
Yeah, that's what we tend to do is like if you want to
Yeah.
say, okay, something, it's just literally it's just whatever text you type in, it shows them that text, and then you can say, same as you can say computer or user time, so force them to stay there for 10 seconds, or they can click
Yeah.
next when they're ready.
But the benefit of doing like an instruct trial rather than just putting it like as a study trial is that the formatting looks better of the text.
Yeah.
So maybe next time we can go
Yeah.
through the
All the
different
trial types.
existing trial
Yeah,
types
that'll be
and
good.
then how
Yeah.
to put in new trial
That'd be
types.
awesome.
Yeah, that's the big thing, like making new trial types.
So what are other basics to get through them that we might want to talk about next time
Did you guys
before we
want to
start to go into more complicated things?
At some point we should show people how to get their data and like what the data looks like, how the format
Oh, yeah.
looks.
That is important.
But I mean, that's in the docket, right? Of like talking about formatting data and little things that are niceties to make it better. Yeah, I don't know. Was that good for? I mean, I guess you ask KP. KP's the one who has the least experience. KP, does this make sense to you?
Yes, so far it's been great. It
Okay.
makes me love this program so much than what I currently have to work with.
Yeah, like I wrote this to not have to force people to code stuff for the most part. Like 90% of the stuff is just mess with Excel and then very minimal coding, and it's getting better about like separating what code you even need to look at, if any.
Mhm.
And hopefully it should be more partitioned soon.
Yeah.
And then we'll get crazy. Okay, hang out over. I'm gonna hang up on
Thank
the
you
world.
so much.
No problem. Awesome. I don't know how to put this. Like, does this just stay forever on the internet?
I don't understand.
All right, we'll figure this out later. Bye, internet.